We're going to continue with step 2, assess and prioritize needs, continuing to focus on just the assessment part of that. And this time we're going to look at PSSA and Keystone data to see what does it show. There are many different ways to look at our state student achievement data, whether that is from the massive spreadsheet that is sent from PDE to the LEA, or if that spreadsheet has been uploaded into a data warehousing tool and we can produce pie charts and bar graphs and other ways of looking at the data. For our purposes today, we're going to look at eMetric. The logo on the top right-hand corner of the screen is for eMetric, Data Interaction for Pennsylvania Student Assessments. In eMetric, we can look at student achievement data as a comparison to the state average. We can look at points received per anchor. We can look at the multiple choice versus the open-ended. We can look at the percent proficient and advanced, and we can look at the average scale score per grade level. This is an Algebra 1 Keystone Performance Summary by Assessment Anchor chart. It is found in eMetrics in the District Summary Report on one of the multiple pages of that report. So how do we look at this data? What could we do to make some comparisons and understandings? We could look at the total possible points, the minimum estimated points needed to pass. We can compare that to the district median points earned. We could look at the district median points earned compared to the state median points. So let's see, what do the trends show us in the data? So what if I looked at the reporting categories under Module 1 and I looked at the district median points compared to possible points? Well, I see 2 compared to 10. I also see that the district median points compared to the minimum estimated points needed to pass is 2 compared to 4. So yes, lower than the minimum estimated points needed to pass. But if I take that lens and look over to the state median points earned, I see my district median points may not be as far away as what the minimum estimated points needed to pass would be. So a 2 in district median points earned compared to a 3 in state median points earned, there's a smaller gap there. And the trend seems to continue as I move on to linear equations, linear inequalities, even if I look down at data analysis, but there is a bright spot there with functions and coordinate geometry where the district median points earned is the same as the state median points earned. Is this even important? Are the median points earned important? Well, somebody must think it is because it's actually included in this report. So what if I looked at this by disaggregating the data, by taking the first-time test takers out from the retesters and separating those 2 out. So let's look at the district median points earned and the state median points earned in the purple box. So for first-time test takers, oh, look at that. They're actually scoring a little better than the state or the same as the state in all categories except for data analysis. And what if I looked at that directly below that purple box for the retesters? Well, they are also scoring the same district median points earned as the state median points earned in all categories. So that certainly is interesting. What if I looked in the green box, district percent of students earning more than minimum points compared to the state percent of students earning more than the minimum points? Well, now I see a little bit different. For Module 1, the district percent is higher than the state percent, but as I look down through operations with real numbers and expression, the district is lower. Linear equations, the district is lower. Linear inequalities, the district is higher. Interesting. And functions, lower than the state. Coordinate, higher than the state. Data analysis, oh, look at that. The district percent of students earning more than the minimum points is at 15.8 compared to 32 for the state. Well, this certainly prompts more questions now that I have disaggregated the data and have started looking at our first-time test takers compared to our retesters. Let's move on to PSSA data that is available in eMetrics. And let's say we're going to look at the points received per anchor. So on the left-hand side of the screen, I have grades 6, 7, and 8, and I'm looking at math, and I'm looking at the reporting categories of the number system, ratios and proportional relationships, expressions and equations, etc., etc. I could compare the district average to the state average. And so as I glance down through that, I may begin to notice some patterns. What patterns are you noticing? How about if I look at geometry? And I notice in 6th grade that the district average is 5.2 and the state average is 5.4 out of a total possible points of 10. So that's one area where the district falls a little less than the state, but is also roughly around 50% of the total possible points. Whereas in almost all the other categories, except ratios and proportional relationships, we're hitting at that 50% or so. Let's look at grade 7. How'd they do in geometry? Very similar to the state, just a 1/10 of a point higher, but again, falling actually a little below the 50% of the possible points. Any other strengths or areas in need of improvement that you're noticing? All those questions prod more questions. So I'm going to go back to eMetric and I'm going to look at the individual performance report, choosing the grade and the year, and then get the report. And I see this. Well, what can I do with this? Looking at each and every student's would be difficult. So how about I hover over the multiple choice total or the open-ended total to make a scatter plot? What? A scatter plot? Yes, a scatter plot. When I hover over that open-ended, I then populate a text box. And the text box gives me different options to look at this scatter plot. I'm going to choose plot against. Then the next text box, I choose mathematics. And then the next text box choice is reporting category. And then finally, I'm going to choose geometry to then produce the scatter plot. What is this? Yes, we have a scatter plot. I have an orange line there showing that on the vertical side, it's showing all of the geometry, M7, C-G, all of the geometry possible points, and it's comparing those points to all of the math open-ended for grade 7 for the students in this district. I could grade 7 in particular. So each dot represents a student. The darker the dot, the more students with the exact same score are layered on there. So if it's a very light colored dot, there may be 1 or 2, but as we get into the darker shades of blue, there are 3, 4, or 5, whatever number of dots layered on top to represent that there's more than one student with that exact same score. It is a correlation, and the correlation happens to be 0.75. That's a pretty strong correlation. And what do I know about that correlation? So if I look to the left-hand side of the screen, I see there are quite a few students here who earned 0 on the open-ended, and the most that that group earned would be maybe 7 points total in geometry. There are quite a few students also who scored a 1, a 2, or a 3 in the total number of points for open-ended and have earned fewer points on the geometry as well. If I go all the way over to the right, you see this student right here has earned 11 points in the open-ended and has one of the higher scores for geometry. what the correlation is showing is that fewer scores on the open-ended are also related to fewer points earned in geometry. Now, there were a few students here who are outliers, but here is our correlation band, and here is the range, a standard error range for that correlation. There are 641 students represented here, so it gives me a good sampling of how our students in this particular district are scoring on geometry as compared to all of the open-ended.